This is part 2 of chapter 1 again. Let me pick up where we left off in this thing right here. So this is what a memory address would look like on one of the, it's kind of like a slide that you could see with this thing. So what is a secondary storage? Anything that you write to, a USB, floppy drive, CD-ROM, these are secondary storage. They're non-volatile, means that they don't erase. They do not erase when there's no electricity or no electrons in there. So this is what secondary storage by definition means with it. I hope you know what an input device are, anything, so you read the slides, it tells it all. Output, anything you show up to the printer, monitor, pretty much self-explanatory with this thing. Software refers to a program that runs on a computer, and I want to give you these two categories. This is very important, as operating system and applications, as classifications of two different software with it. And remember now, your application is a subset inside of your operating system. Anything that you build as an application, you got to have the Windows SDK, Ubuntu SDK, the Mac SDK in order for your application to sit in it. I do want to point out this is that the operating system can be categorized according to the number of users that it can accommodate, that's one, and the number of tasks they can perform at one time. So let's see, if you're building accounting software, that accounting software has to accommodate multiple users at the same time and to perform a specific task at the same time. Alright, so that's what an operating system has to be looked at when you actually look at this thing. Alright, so I kind of gave you the two. Control the system resource is what controls the amount of RAM. Resource, that's resource. RAM is not for everybody. It's not for every software, so it has to be controlled a certain number of ways with this thing. Provide with the user means and interactions with the computer. So I want to ask you these two in the wording that I just said to you in a certain way with this. I'd like for you to know this as well. I'd like for you to know what a programming language is. How do you define a programming language? It's a specific language that's used to write computer programs with this thing. Syntax, like I mentioned to you, what's our syntax? Let's come down here and take a look at your operating system with it here. This is the slide that I do. This is a test question slide right here. You need to know this slide. All right. This is a test question right here. I'd like for you to know that when you actually build a computer system that actually has multiple applications, and how when you build these applications, it becomes a very resource memory management in anything that you build with it. So this is the definition of a program language. It's a set of instruction a computer follows in the order perform a task. A program language is a specialized language written in computer programs, used in computer programs. A computer program is a set of instruction that enables the computer to solve a problem or perform a specific task with this thing. So collectively, these are what's called algorithms. Algorithms with this thing. This is very important with it. I'd like for you to know what is a variable at this point. So a variable, as you see, as we come down here, as we look at the different type of variables with this thing. I'm going to skip ahead here a little bit. These are the different programs, but I don't want to get too far with this thing. A variable is basically a symbolic name made up by a programmer that represents a location on the computer RAM. Alright, so if you say like int x, you declare int is the data type, x is the variable, and that x is the data type of int that can actually receive a data type of an int. That's a memory allocation that you just set up, and a byte in a int, it's 4 bytes. Okay, so versus something, if you recall, what's a double? Double is 8 bytes with it. So that's where the memory management comes in, and why do we do all this size and different? It's all about precisions, all right, with that as well. So if all this should be coming back to you if you had me for 1436 with this thing. bytecode instructions. So you look at, there are some concepts that are common to virtual, to keywords, operator, punctuation, program-defined identifiers, strict semantic rules with this thing. So when you move from C++ to Java, you will need to be able to understand some of these types of transition. Every programming language has keywords, different types of operators are pretty much consistent, less than, equal than, plus, addition, subtraction, their order of precedence, same thing with it as well. When you compile, here, this is our basic skeleton with this thing. So what should this say? This should say what? Hello world, right? So this is the class that you're writing. Remember now when you build the hello world, you save your file as hello world.java, and then you compile it as what? Java C space hello world.java. To run it, what you do? Java hello world, and you hit enter. It should give you a hello world with this thing. So what happens in the program process when you actually define a program? You're compiling that code. All right. So when you're in the program process in which you are involving is defining the programs, what to do is basically you need to compile the code by using what? Java C. Make sure you know that. I'm going to ask you on the exam, I'm going to ask you, how do you compile? I'm going to give you a sample file. I'm going to ask you, how do you compile this particular file? So the command instruction is Java C, the name of the file with the file extension with it. So, and how do you run it? Okay, so you run Java. That's what that is. Java and the name of the class file with the same. Bytecode instructions are what? Bytecode instructions are basically you read and interpret by what's called your Java virtual machine. You also know that as an acronym as JVM. I think I get to it down here. Just a few key reserved words you need to know. Java is case sensitive. Java keywords cannot use as predefined identifiers with this thing. We call it 1436. What are identifiers? They're your variables, functions, and constants with it as well. So when you actually have one of the things I want to ask you, one of the tools, design tools used by programmers when to create a model of programming is called what? You write your pseudocode. Pseudocode is your native English set of instruction, cookbook type of style with this. So you gotta know what a pseudocode is, and then you convert to your code with this thing. The second thing is I want you to know is runtime error is usually result in logical error. So when you actually run, there's three types of errors when you compile a program. The first error could be a syntax errors. You left out a semicolon, you misspell a word, etc., etc. The second type of error is logical error. Logical error is the most difficult error that you can need to find. And there are times that you logical errors, like you tell the computer how to do something and it doesn't. It doesn't know if it's right or wrong with it. So if you're balancing a checkbook, deposits and debit, and you actually took one of them out of context and you did the wrong one, that's a logical error. The third error is what's called runtime error. A lot of times they are connected with it, but there are also different data types can actually connect to runtime errors with it as well. But at this level, I like for you to know logical errors and syntax errors. If you're new to the language, syntax errors is probably probably the most popular one. Until you get into it a little bit more, logical errors can cause runtime errors with it as well. So moving forward, this is what a variable is, okay? Make sure you know what a variable, I gave you a definition of variable. So this is a variable, alright? So this is the definition. Make sure you understand what a variable, you're allocating memory for that variables with it as well. Let me check here.